Yeah, hey, Sjoerd, Nikhil. Welcome to the session. Glad to have you guys here. So before we kind of kick off and get into the crux of the session today, it'd be great if you guys would introduce yourself. A short one about a little bit about your background in terms of how you started your career, how you got into robotics, and what you do today. So I guess for those who don't know, there's a little bit more context before we jump deep dive into the session. Maybe Nikhil, you can go first, and then followed by Sjoerd.
Yeah, sure. Great. Yeah, so I'm Nikhil. I take care of the technical things here at Botsync. I'm also one of the co-founders along with you. Um, so robotics for me was a fascination from childhood, actually. It's always the thing that you watch Iron Man and then you want to start building robots. So that was the thing for me as well at some point of time. But it became more of a reality towards college. So started building more and more robots when we were in college doing projects together. We participated in robotics competitions that actually added or fueled this interest towards robotics. Finally decided to make a career out of it. But the way we decided to do that was to build a company ourselves, build robots that we like to see. And then started realizing commercial impacts of those, started building the company more and more, started growing the company out. Today, we work on several kinds of technologies that are oriented towards the software for the automation field, robotics for factory automation, so on and so forth. We take part in a lot of multidisciplinary engineering work, and I head a lot of these teams internally. Very quick intro from my side, but yeah, over to you, Sjoerd. Maybe you can introduce from your end.
Thank you, Nikhil, and thank you, Rahul, for having me. My name is Sjoerd. I'm a Belgian national, engineering background, and a long career in B2B high-tech strategic sales, strategic commercialization, going to market strategy, pricing, partnerships, networks, etc. I've started working first part of my career in a multinational company, in an MNC. Then I joined a family company, rather an SME, and these last couple of years have worked at startups. And I think that's a perfect trajectory. You learn the ropes, you learn the processes, you learn the systematologies in the MNCs, and then you can apply them in what is sometimes a greenfield, or what is often at that stage of growth less structured than a startup. So I'm enjoying this a lot.
Yeah, I think thanks, Sjoerd and Nikhil, for the intro. So I think we'll kind of go through the session a little bit, focusing about like career in robotics. What does it mean to be here in this space? There's a lot of hype about humanoids, physical AI, but I think we'll try digging into what it really means from being inside a robotics company. What does it actually mean? What is reality versus what is hype? And what is reality versus what is fiction in the past? So Sjoerd, maybe I'll start with you. You said that you worked in strategic sales, worked with an SME, and then I believe you started shifting a career into robotics with Venti, and then you went to Speed Cargo, and then now you're working with us. So it would be quite interesting to see or hear from you, what was that shift like from, I think, like a company like Barco into a robotics startup? Not a robotics big company, but a robotics startup. What does that shift like for you? What is the difference in work culture and the work being done?
Yeah, two things strike me: one, similarities, and one, differences. On the similarities, I've been in many different industries. I've been in robotics the last couple of years. I've been in satellite communication before that. Before that, I was in display technology. Totally different markets, different customers, different vendors, different everything, different technologies. However, from a commercial perspective, the way of doing business, the way of developing and going to market strategy, the way of managing a sales team, the way of setting up a pricing mechanism, the way of organizing your marketing, your customer service, all of those processes show a very high level of similarity because they are all in the B2B high-tech space. And so when I said earlier that I learned the ropes at Abarco and then can apply them in the other companies, that's where that comes from. And those similarities are very, very striking. It is in the end all about discovering the customer's pain points, discovering the customer's decision-making cycles, and applying what you have as products as technologies to that. Differences, what I noticed in most of these robotics companies is that whereas in other markets, there is often a very compelling reason for the customer to actually buy. That seems to be less the case in robotics. Let me explain. When I was in digital cinema, it was pretty obvious. If you wanted as a cinema, you wanted to show the new Star Wars, then you'd better get a digital cinema projector because George Lucas wasn't emitting it anymore in 35 millimeter. So the reason to buy was there. You still had the competitive play, but at least the customer, quote unquote, needed to buy. Satellite communication, very similar. If you're on one of the 14,000 islands in Indonesia and you want internet, you're not going to get fiber. Antennas don't work. So it's internet or nothing. It's a satellite or nothing. In robotics, that seems to be less the case. Customers do see the ROI, savings on drivers, 2-3 years ROI. They do believe that the technology works, so the major hindrances are gone. But reality is that their factories do still run more or less okay the old-fashioned way. So it's still a bit more nice to have than it is a need to have in my experience at this moment.
Yeah, a few questions there. So what you said is similarities in terms of building a team, go to market, identifying the customer pain points are the same. So in the case, the differences wise, the challenge we have in robotics is sometimes it's a nice to have than a must to have.
Yeah.
Right, compared to like I think what you were mentioning earlier with the cinema industry. You're working with Darko, I believe. Have you kind of seen that change? I think over the past couple of years, and do you see like a point where it does become an essential must-have, or do you still see that it's going to take a fair amount of time before it becomes if I don't have this, I can't run my operations?
Well, it's very often a gradual growth, and then all of a sudden an inflection point. I've seen this in the other industries too. How far are we from this inflection point when it becomes a need? That's probably hard to predict. But what I do see is that the major typical blocking stones of technologies are one by one disappearing. People now do believe that it works. They've seen it on YouTube, they've seen it in reality. So the fear of technology, of the fear that this is not going to work in my environment, that is disappearing. Prices are coming down, robots are getting commoditized, so the ROI aspect is also getting better under control. So it's that's not enough to really turn it into an I must have it tomorrow, but at least the major hindrances and the major blockages are disappearing. So I do see this as a continuous gradual growth over the years to come.
Perfect.
Could I chip in? Yeah. So do you if you compare to the early stages of like Lucasfilms and like George Lucas, right? Like when they initially came out with Star Wars, it was not seen as something that was common in Hollywood, right? And that's one of the reasons why the movie was self-funded. But once it kind of hit theaters, it became so big that there was like a next set of entire genre of films which followed exactly what Star Wars did. Like with the entire idea of like space and the idea of like bringing in characters that are out of this world and so on and so forth. Do you see? Can you draw some comparisons between what that looked like and what it is right now? Sorry, I'm asking a question here, but like, just curious about this actually.
Yeah, George Lucas also Star Wars is an icon, and that really makes it happen. Of course, you could argue that in automation, self-driving robot types, that Elon Musk plays a big role in that. But then again, George Lucas was not controversial. Elon Musk is. So whether he's helping the cause or hurting it is more of an open question. Um, Rahul mentioned humanoids. That certainly raises a big additional interest in robotics, and even in the customer base that we are talking to now, which is very conservative, right? Food and beverage, automotive, those are conservative industries. Even there, I hear customers at least ask the question, do we have to look at humanoids? So that too will definitely help in bringing the notion of robotics forward and more acceptable.
Well, I think that's something interesting. Nikhil, you mentioned a little bit about Iron Man kind of creating that spark of inspiration to get into robotics. But I feel like a lot of fiction movies also create like a expectation of robotics, which practically is very hard to meet. I think, especially we've gone through building a board from like a simple AGV AMR a long time ago to starting to kind of expand upon that now. And so, anyways, I've experienced the struggle of making something work, even if it's a small component reliably, being not an easy task. So I think for you, specifically, Nikhil, since you're building the tech, uh, how do you draw comparison between what's out there being hyped, what's there in fiction versus what is actually feasible to build and practically deploy? Like what Sjoerd is mentioning, that bots are starting to work, but the bots are starting to work today have been being in design for the past couple of decades, or at least a decade.
Right. Yeah, I think like there's a difference between what's realism and what's inspiration. So while Iron Man is inspiration, I do think like realistically it did take us a while as well before we got bots up and running. And I think that's the general case with anything in robotics. It does take a while because things are hard from an engineering perspective. A lot of things go wrong fundamentally. Initially, when we were kind of trying to build these things, like we had a very ideal view of our timelines, our schedules, and what we could get done, and so on. Actually, a lot of it changed once we started putting the products out there to customer facilities. So initially, we were trying to build robots, like I said, for ourselves, right? And then there was a kind of point when we started thinking that okay, these robots have to solve something for the customer or have to move the needle for the customer. Um, Actually, that's the point when we started thinking what is realistically doable, what is practical robotics, and practical robotics actually means something that eases up the customer's process flow or eases up the customer's use case. And that means things have to work all the time. That means that it genuinely needs to solve a problem, and that means that it has to be faster than what exists today. All of these problems are fundamentally complex, right? So it took us a while before we started realizing that those were the problem statements that we needed to focus on. But once we did start focusing on them, I think we started like solving those as well. Today, I think like we spend a lot of our time obsessing over the 1% of issues that happen. Actually, we assume that our baseline is that it's already working, everything moves, is actually like better than their process today. And that's the baseline that we try to establish, we try to push down, right? And we try to focus on that 1% that actually adds value. um, I think for your like initial for the discussion point that you shared, actually it is like very practical, right? Like it does mean that what you see in media out there is probably not what it is realistically. Realistically, you're focusing on a completely different set of problem statements. I think that's something that we've learned through experience.
Interesting. Maybe going back to Sjoerd a little bit, right? So you spoke about how customers are still trying to find that, make the business case work before they actually implement something that works. So considering the hype that is there in the market and fiction that is there, how do you manage like typical expectations with this is what we can do, this is what the ROI can deliver, and manage customer expectations that way while understanding what is practically feasible based on what considering what Nikhil's talking about, practical robotics, what is actually feasible today versus what they think can be done. Like, how do you manage an expectation generally while speaking to users?
Yeah. Well, it's always a matter of deeply understanding what the customer pain really is. And in our space, those pains can be very, very different from customer to customer. Some are concerned about ROI, saving on salaries from forklift drivers, replacing that with investments. Others are concerned about a smoother process, not having to retrain and hire forklift drivers. But others are purely concerned about safety. I was talking to a customer a while ago who had 6 months past a deadly accident in his warehouse. Now, that's an incentive to take the human element out of the equation. Another customer needs to go or wants to go to automation because his president came in and scolded him because his factory looks old-fashioned versus the other factories in the group. So the pain points, the needs, therefore the motivations of customers are very, very, very different from one to another. And you always need to start from that. Your next step is then, can we overcome those pains? Can we fulfill with our products and with our solutions? Can we do that? And the moment the customer has a pain, if at least you can alleviate that pain, if you can do it fully, fantastic, but at least if you can put him on a path where it starts improving his situation, most customers will definitely go with you and work with you. I've not really encountered the inverse, where a customer expects the moon, the star, and the whole universe, and expects it by tomorrow for free. Highly unrealistic expectations I've not come across. We have come across a number of practical situations where, purely for logistical reasons, it's not possible. If the hallway is smaller than your robot, then it doesn't work. But that's not in the level of science fiction type expectations. Those I haven't encountered so far.
Interesting. I believe we had a conversation a couple of weeks ago. I think Nikhil and I have been speaking about it as well. Because even if, let's say, the expectation is grounded and compared to a person operating a forklift, for example, I think we come across cases with customer expectation is the autonomous version of the same should operate at the same speed as a person driving the forklift. Right?
Yes.
But maybe Nikhil can comment on this later on as well, in terms of where are we where's the limitation today? What does that journey look like to get to that point? But from a commercial perspective, like, what does that mean from a conversation? Let's say, because they're using one forklift driver and one forklift per shift to do something. And a bot today can't replace that 1:1 yet because you can't drive at the same speed. You can't kind of, do a maneuver while lifting the rack, for example, which a bot can't do. How does that conversation go from a commercial perspective for Sjoerd, and then maybe Nikhil's side? Like, what does the journey look like over the next few years to get to that point where it's not fiction, but we're matching what a person can do in a facility?
No. Again, it comes always back to the same point. What is the pain point of the customer? If his pain point is safety, then taking that forklift driver out and replacing it by two bots is not so bad. If his pain point is his president breathing down his neck, then showing two robots is even better than one. So there it works in your favor. If his intake or his pain point is ROI, that you need to see, can you match it in pricing? And if it's productivity, then it's a difficult conversation to have indeed. But again, it comes down to what is exactly the pain point. It's not. Nikhil said that we need to be faster than, ideally, or better than the human equivalent. Ideally, yes. In some cases that matters. In other cases that does not matter at all.
Yeah, I think the other aspect to add on is, like, when you think of an automated solution, it doesn't help to do like a 1:1 comparison. It actually helps to look at the process and the solution as a whole, and whether it's actually optimizing a lot of facets. Like what Sjoerd spoke about was the safety aspect of it, right? So that's a major improvement that's being brought in. in addition to any form of like benefits that are offered for manpower replacement, if that is a consideration over here. But in these kind of scenarios, actually, like it is very useful to look at the end-to-end solution. That's the most critical thing. Like it's not very useful to just cherry pick like one aspect of it and just do like a direct one-to-one comparison. Most of the time, I do feel like that's where the conversations get misled. Actually, when you look at like different facets of it and put everything together, then actually like things start to make sense a lot more. In a lot of our cases, actually, we've optimized throughput by looking at the source of input to a robot. That actually like mattered quite a bit. It mattered more than what we had initially assumed it to be. So I think those kind of aspects matter quite a bit as well. So that's one more point to add in actually with it.
No, I agree. But having said that, there are some practical aspects in real life where a robot or an AMR should be able to cope with it. I'm thinking, for example, factories are real life environments. The floor is not always marble flat. So whatever it is, an adaptive odometry or something that can cope with wheels slipping or wheels going over potholes. I mean, that should be something that improves the usability quite a lot. The same thing on slopes. I mean, not everything is perfectly flat, and not being able to drive over a 5-degree or a 6 or a 7-degree slope where a human forklift has no problem with that at all. Those are things where we should at least match the human forklift. But those are the more smaller technical parts.
Yeah. Although like some of the advancements that are coming up in this space like look very interesting. What's coming up with the combination of AI and robotics put together, that's actually like really interesting. There are like future applications where like robots are going to look more realistic. I don't think it's too far away. It's just not here already, right? Like, but it's just a matter of a few years, and we would see like cases where robots are kind of like visually learning based on cues. That's like an interesting point to reach, actually. I think like the moment that happens, a lot of these questions would get answered automatically without having to explain a lot. So that's something to add in as well.
Yeah, I think like when we spoke about like physical AI in terms of like not defining controls systems to handle cases, but let the bot figure out certain things on its own over time. The main concern I typically have is just with safety. I think Sjoerd mentioned as well about people automate with safety in mind, but if you're adding components to the bot that maybe makes it more capable of handling corner cases, but introduces a lot of safety concerns, then how do you kind of juggle that becomes like an interesting challenge to think about. Because today, bots are simple in terms of what it does. So it's easy to build safety systems that are actually fairly foolproof. But the more intelligent you make it, the more capable it is to handle corner cases. How do you ensure safety in all those conditions?
No. And there, the barrier is immensely much higher for robots than it is for the human aspect. Think of self-driving cars. There are, I don't know how many tens of thousands of people dying on the roads every month, every year. But if a Tesla self-driving car hits one person, then it's all over the news. So in automation, I mean, in factories, every operation director will tell you that there are lots of incidents with the human drivers. I mean, they hit stuff, they damage stuff. But if the robot hits one time something, then the world is too small. So we are held to higher standards than the human drivers.
Yeah, absolutely. I think it's kind of shift away from industry and expectations a little bit more like working in a robotics team, right? I think we had this like conversation internally that building a robotics company is like building 3 companies. You have an entire sales part to solve. You have a product to build, which is not like one particular aspect, but you have hardware, you have software that needs to come together at the right places. And then you have the entire part of operations, supply chain, logistics, customer success support. So sometimes it can be fairly overwhelming to deal with all the different moving pieces. So what has your experience been? I think maybe Nikhil can go first. A little bit about how it's like to work and build in a multi-faceted slash multidisciplinary team, and what does it take to kind of grow that team? And then maybe Sjoerd can go next from a commercial team. How do you interact with the different teams to really make something happen?
Yeah, so okay, so first of all, to build a robot, it's one of those unique sectors where you actually do need to have experience with mechanical design, then you need experience with electrical embedded systems, then you need experience with software engineering, and that's divided into multiple parts where you need experience with building autonomy software, which is like your navigation, precision docking, and so on and so forth. And then you have your web stacks, which is for like software engineering and so on. You actually need to have like awareness about all of this to build a robot fundamentally. That's that. I mean, the statement in itself is like a very complex statement, actually. Like, so it's very hard to bring together people from all these disciplines, first of all, and have people who understand just enough about everything such that they can coordinate and manage all of the information that's flowing between them. This like just putting together this team gets you to the part to build your first prototypes, your POC products, and so on, right? And then after that, the challenge becomes manufacturing. Like you have to get this consistently running over and over again, which means you're again taking on one more facet, which is the manufacturing engineering, which is less to do with product design and building something, but more to do with processes, supply chain, and making sure things arrive on time, things are put together properly, the quality is controlled really well, quality is assessed properly, so on and so forth. And that becomes like another facet of engineering. And what happens when you combine all of this is you have to have like coordination that's going on very smoothly. You have to have your engineering team members actually talking to each other without being at each other's throat all the time. Because like, usually in a case like this, the software engineer is blaming the hardware engineer, saying that it's his problem to solve, his or her problem to solve it. And then the hardware engineer is blaming the software engineer, saying it's his or her problem to solve it. And you're always just like in the middle of this conversation trying to sort it out. Yeah, it's like it's very interesting to be in the middle of all of this as an observer. But if you're inside of it, it's actually a pain to solve it because it's more of a people interaction problem more than anything else actually. So yeah, for me in particular, actually I got to learn a lot from the people around me. So I'm from a computer science background and I'm a software engineer. So during my college days, I've focused a lot more on AI, software engineering, as well as robotics. And within robotics, I mainly focus on the software elements, which was how do you get a robot to navigate from point to point. That was the sole problem statement that I kept focusing on. And later on, started figuring out that I need to understand the rest of the system to build this. And then like spent a lot of time actually with the electrical engineers doing the wiring work, and I'm horrible at it, right? I my hands shake all the time. I can't crimp something, I can't solder something, but I had to learn all of this, try to do it
Nikhil
anyway.
has soldered my hand many times.
Yeah. So okay, and like a very funny story between us is like once Rahul was holding a nail, and instead of hammering the nail, I hammered his hand. Like I hammered this. But like it actually helped a lot because I learned so much through all of that. That today actually I can like I mean today I'm like decent at kind of like pulling the strings for each of the teams. I know that when my hardware team is struggling, I know what softwares to plug in over there to help them out. And I know the other way around as well. Like the permanent fix is normally in the hardware. And I know how to like kind of like stretch it out such that the solutions are put there in place. Nothing breaks at a customer side, but like internally we're pulling all these strings to make sure things are running smoothly. But yeah, like from all of this, the conclusion is that it's pretty hard to build a robotics company. You do need to have like all of these skill sets. You need to understand that a lot of it is more process oriented than fundamental design. You need to spend a lot of time testing, doing QA, and that's when you actually learn all of this. So today I spend a lot of my time doing product testing, kind of like just defining what teams are supposed to do than the actual coding itself. And I managed to build a team with good coders, good developers who can actually execute this, which is, I feel, at this point of time for us, the right place to be actually.
Yeah,
So yeah.
I think that's like an interesting point, right? Because if you want to thrive as an engineer or build a robotic startup, it's very hard to do with just like one domain expertise. You can't just be a mechanical engineer who does not know what's happening under the hood electrically or on the software layer. But I think I had like one point which I wanted to kind of deep dive into about building MVPs. So most startups, I think if you go through like any playbook for building a product, the idea is build an MVP which you're like embarrassed about, ship it out, collect features, and then iterate really quickly. But my experience has been like it's really hard to do that with a robotics product because if the MVP hits someone, like you said, if you hit someone there, that's the end of your product, end of your company. So it seems like the benchmark for what an MVP is fairly high as a robotics product. So maybe I think both of you can kind of go at this, but like, what does that mean? Like when you say MVP for a robotics product, what do you guys think of as the minimum requirements that it needs to have before you can even try pushing it to the customer? And what does that mean from a timeline perspective? Get it out into the customer. I don't think it's going to be a 2-week process. It's going to be at least a couple of months. But experience-wise, what does that look like? And what is that definition of an MVP for a robotics product?
No, yeah, I fully agree with that. I'm a firm believer in the try fast, fail fast, learn fast, adapt fast. However, in our environment, which is always a mission critical environment for the customer, that doesn't work. You cannot fail fast. You cannot interrupt the automotive production line because you're learning fast. I mean that doesn't work. So the minimum critical MVP that we need to bring is something that fulfills the job from day one. It doesn't necessarily have to have all the features. It doesn't necessarily have to be able to do it in a fleet of 500. But at least if the job is to move stuff from point A to point B in a reliable, safe way, then the MVP needs to fulfill that. So indeed, again, the barrier is higher for us than in many other industries.
True. Speed matters a lot as well because if you only have 12 months of cash or 18 months of cash left and you're taking 12 months to put out an POC, you have 6 months to prove that it works, which sometimes is not a great amount of time. And I think we've gone through this struggle before as well. We spoke about it a few times, but what is your perspective on balancing the need for a quality functional product versus the pressure of shipping fast to make sure that you can kind of build up on your targets, build up on your metrics to get to the next stage? I know we've had a lot of debate about this, but
yeah.
I
mean, I think this is a big source of argument normally. Okay, so I mean, in terms of like to establish a context, I suppose like the fastest we've done a hardware development, meaning like pushed out a robotic product, is 3.5 months, right? So that's to set a context. Like even if we're doing a POC, it does take like an entire quarter to put together things actually. That actually is what is realistically possible. And the reason for that is that you can't simply like put together a hardware box, like a metal box, and just ship it out to a customer which doesn't move, right? Like it makes no sense actually. Like, what we're supposed to do is just like fulfill the fundamental need that, okay, like for example, if the robot's purpose is to move material from A to B, then at least it has to be able to move some materials from A to B. Let's say it's doing the 60% of the time. That's at least like a benchmark for us to go on and like push it out to the customer before we start talking about the rest of the 40% where it's not like functioning well. In another case, like if let's say it's supposed to do a pick and place operation like a robotic arm, and the initial POC has to actually execute a pick and place before you can push it out. If you're kind of like building a software, in most of the cases you can actually push out a product that's barely functional, in the sense that if you have like manual forms that you're using to fill out information, you just have like like the entire process set up in the back end manually, which is not automated yet, you can still like push out the product in a way that at least you get to your initial customers to pull feedback. But in a robotics case, actually, it does matter that the base functionality that you're describing is fulfilled before it goes out there. So yeah, I think it is a bit different in the robotics sector. But having that fundamental iterative idea or mindset does help. Like even if the time scales are 3 months or so, like still having the notion in your head that every week you need to deliver something, right? You need to showcase some improvement in the product helps in establishing an internal technology mindset, right? Because for our teams in the past, we have had scenarios where we've stretched out timelines for 10 months, up to a year actually. And the challenge with that is when you stretch out something for so long, everything around you in the world and the market is changing, right? So you don't have internal feedback that's running that quickly. At least for an internal point of view, it's very valid to have like milestones set on like weekly basis or 2 weeks once basis, because you need to have something that you can demonstrate, you can show internally that proves that okay, you're growing towards like what is necessary. And this helps to establish feedback loops very quickly. So yeah, I think like that kind of works for us today actually.
That's quite interesting as a point, right? Like, even though it takes time to build an MVP over 3.5 months, it doesn't mean your first point of feedback is at the end of 3.5 months.
Yeah.
That's something we have learned the hard way, because
Yeah.
that weekly check-in does matter quite a fair bit.
Yeah.
But I think the other big learning for us, at least over the past 4 years of building products, I think our first MVP or getting something out took maybe a year and a half to get it to a point of functionality. I think, like Nikhil said, the recent ones has been in a quarter or less. The one key takeaway has been that there's a general notion that to build a robotics product, you have to own everything in the product, from like the design of the wheels, the motors, the drivetrain, all the way to the software there. I feel like one thing which is changing now, and it's more accessible, is there are people who have built certain things before. For example, there are cameras with pre-built algorithms to detect certain kinds of options. There are hardware products out there in the market which functions a certain way that you want to do it. So I feel like one lesson for us has been to kind of leverage that ecosystem a lot more than what we did like 4 years ago. And that becomes a big component of one big component of being able to cut down your MVP timeline without compromising on functionality. Because if someone solves something over many years, you can kind of ride off of that experience and leverage a partnership. And you can focus on certain things that you think you can bring value to the table instead of trying to do all of it yourself. So that's something as a general philosophy, we've been trying to embrace a lot more of collaborating rather than trying to go the journey entirely alone. Still a journey for us to figure out that collaboration model, but at least we're starting to see kind of realistic, tangible impacts. Maybe kind of short, moving back to you from a commercial perspective. I think we had these discussions about having the trained team which is technical enough to understand user requirements, build a case, but as a sales function, they need to be aggressive, hungry enough to close deals. And maybe like some places be shameless enough to keep following up until something happens, right? And that's very different from a building mindset internally. But I think a common denominator for both the speed and urgency still stays the same. So in your perspective, what does that mean, to function in a commercial capacity in a multidisciplinary team? How do you see interactions with other teams that helps your job a lot when they're trying to work in a silo?
Yeah. Well, I've had the good fortune of, through my career, always work in a hardware type of environment. It's never was a company that builds an app and releases it. It's always been something tangible, something that you can touch, something that you actually deliver to the customer as far as hardware is concerned. For me in that environment, there are two factors that have always been super important to be able to do the job well. The one is the sales, marketing, after sales or customer service factor. Those three functions for me need to be extremely well tuned to each other Marketing ideally needs to feed the customer by raising the awareness, by getting leads, by getting the name recognition, the reputation out there. Sales needs to bring in the customer, of course, but then after sales or customer service, customer success is super important because they are the real key to the next sale. Even if your product works fantastic, but if the service is not there, then your customer is gone. He's not going to come back. So these three functions need to be very, very well in tune with one another. The second one in a high-tech environment for me is between sales and what I always call product management, the product vision, the roadmap of what we are going to develop. In sales, you always have to sell what you have today, not what you wish you had, because that doesn't work. But at the same time, in a high-tech, fast-evolving world, you need to have a clear vision, and that's where product management or product visionary comes in, a clear vision of where you want to be in 3 years from now. And those two, for me, are very important and need to interact very well. You need to have the vision, but at the same time, you need to analyze and be very attentive to any deal that you lose today. Why did we lose it? Why did we fail? Or any deal where we are not qualified. Why? Which functionality don't we have that makes us lose out? If you only look at one of these two, if you only look at your failures or your misses of today, then you're always fighting last year's battle. That doesn't help. If you're only looking at the future, at where do we want to be 3 years from now, you may be developing something that's entirely out of tune with the market. So the interaction between these two, between call it sales, call it product management, for me is also super important.
Got it. Interesting. I think like on that particular point, because when you said as a salesperson talking to the user, you're selling what is available today and not trying to sell what could be built a year from now, a year and a half from now. So they're very focused on what is available as a current feature set today. But at the same time, like how do you encourage, let's say, people that you're working with to be focusing on selling what is available today, but keeping an eye out to understand what do the customer need or what are they asking indirectly, which are opportunities for us to build for the future. So I know it's like a difficult line to walk because you need to be able to ask questions without making them feel like, oh, it's something we can offer today, but at the same time, you need to start gathering information about what they could potentially offer.
Yeah.
So how do you balance that gathering of information while selling the product as it is today with its current feature sets?
Yeah, well, the answer is very simple, but implementing it is very difficult, or getting people to do it is very difficult. The answer is always focus on the customer pain. No customer is focused on his pain of next year. That'll come next year. They're focused on the pain of today. And so if you can solve his pain of today, then you have the foot in the door, and then you can start dreaming and building with him on how do we evolve this and how do we grow this towards next year and the next 2-3 years. What's common mistakes that salespeople make is, first of all, they sell products, they sell features, they sell rotations per minute, or they sell the kind of metal alloy that something is made of. That doesn't work. Second mistake is that they promise the sky. And for a customer that's hesitant, that they can't rope in immediately, a very common mistake is start promising more and more. Neither of these two work, but neither of these two happen if you don't focus on your product, you don't focus on your not selling, you just focus on the customer's pain point. If you can discover those, you have it half made.
Got it. And I think maybe like kind of go into that a little bit deeper. I think there's this book called the Mom book. I think maybe I got the name wrong, but it talks about how sales is more a job of listening than speaking.
Yes.
Yeah, but I think it's also not easy to get people to talk. Right? So how I'm assuming that B2B robotic sales is very similar, but I think one challenge, like you said here, is proving that it works, knowing what is available today, and like selling the reality instead of selling a promise, which is long-term future. So one, I think from that perspective of the additional aspect, let's say selling a product which has been proven as a commodity for like 5 to 10 years, right? Versus selling something which a customer is not used for. Because in many cases, when we speak to users, even though there are other people they're speaking to, they're not deployed the particular product before. So the challenge is also to kind of, for them, they're not yet figure out what they don't know about the product. And a lot of it is based on assumptions. So
Yes.
how has that journey been of educating while selling at the same time? And do you see that as being a challenge with the regional sales, let's say in Singapore? I think you've experienced selling in Indonesia, Thailand, and across Singapore, apart from a few other countries. And how does that be from different markets?
Yeah, a couple of different elements. The people buy from people; they don't buy from companies. So you need to build up a trust with your customer and at least a minimum level of rapport. You don't need to necessarily become best friends. That's the next step. But you need to build up a rapport and a level of trust. If that is not there, then people are not going to buy from you. Secondly, there are two levels of pain points of buyers. I mean, they are an employee of a company and they have company targets to make. But at the same time, they're a human being. And whenever they decide on something, a major investment or a major initiative like robotics, they always have at the back of their mind, what is this going to do for my own career? And that too is something that you need to listen to, although they never speak that out. But you need to be aware of that a young guy that takes up a new project will be much more eager to go with you and take higher risks because he sees this as the way to shine. Whereas an older purchaser who's been there for 20 years, he's 3 years from his retirement, the last thing he wants to do is turn over the apple cart. So those two, they have nothing to do with the business aspects, but those two are very important elements of listening or observing or understanding that, and that is very difficult to coach, to train, to mentor young salespeople to that level. In our kind of business, we're easily talking about a couple of $100,000 to $500,000 worth of investment, where you need to talk to a whole decision-making cycle, which inevitably involves finance people, legal people, operational people. You can't really work with junior salespeople. They may be good at opening some doors and finding some leads and cold calling, but trusting them to independently close important deals like that's a major stretch.
Okay. I had like a slightly different question for both of you. A lot of the things that we spoke about is something that we both have experienced. I think we spoke about speaking with users, kind of experiencing the journey of talking to customers. And Nikhil, you spoke about how you had to get involved in the wiring part, mechanical design, as well as building the software to get to a point where you could build a robotics product. I think I see a lot of fresh graduates today, a lot of people still in university, who try to skip past a lot of the grunt work, for lack of a better word, to get to a point where they're starting to use tools like a ChatGPT or any of the available tools available online to get past that basic information. If, for example, we had to learn how to wire something, not know how wiring diagrams work, but now they just upload a wiring diagram into an LLM tool, ask for inputs, use that into something else. So, from the perspective of not having the need to go through the grunt work, to be able to start working on things, how do you see that kind of affecting the potential output a person can have? And you still think that even though there is an option to not do the grunt work, it still makes sense to go through some of these experiences for you to become a more valuable contributor down the line in your career, especially for someone joining the workforce today or in a couple of years' time?
Maybe I can go first. So, actually, prior to getting the practical know-how, one thing that's very relevant for someone looking to get into robotics is a fundamental appreciation of physics and math. So we test this in every interview for every engineering position. So every time someone wants to join the company, one of the questions I ask, or like at least a 5 to 10 minute segment surrounds high school grade math. And the reason I ask these questions is because I want to know if they've actually thought about whether there are practical applications to those, right? And robotics is one of those areas where there is true practical applications to the physics and math, Newtonian physics specifically, Newtonian physics and maths that you learn from high school. And that's where things normally start. To kind of directly address this, I don't think it's wrong to use something like ChatGPT to assist, right? The problem is when you're not thinking about the response, right? Like, okay, there's a response coming through. You have to actually spend time reading it and understanding, assimilating that information, and then drawing conclusions from there. So it's very useful to use it like an assistant rather than a direct feed of information. And I think that's the smarter way to do things. I wouldn't recommend like going back in the way of doing things, right? Like we shouldn't be rolling back on years like to what it was like 6 years ago or 7 years ago. So always like good and healthy to adapt to what is the situation today. But there's a way to do it. There needs to be a fundamental appreciation of what goes into the work. And then like start using it in a way that it's assisting you, and use it to assist you in learning first of all, and use it to assist you in doing your work and executing your work. Also like shortcut some of the solutions. It is good to do so. It is healthy to do so because it improves the speed at which output is delivered. So I think all of these factors contributes, but having that fundamental knowledge is very important. And that's something that I've been encouraging to everyone I've spoken to. Actually, I've just been saying that first build up this know-how, then it's better to use what is available.
Maybe sure, from your perspective.
Selling in the high-tech B2B capital investment space is one of the most complex spaces to sell into. So throwing a junior in there is a recipe for disaster. That having been said, sales is, like I said earlier, is a people business. So when I hire or when I select salespeople, I always look at their people aspects. How interested are they in people? How much do they really care about people, and do they really want to help? It may have nothing to do with sales, but people who youngsters who have a career as volunteering, as being part of youth education or volunteering to help poor kids, very often make good salespeople because they have that empathy, they have that orientation, not on themselves, internal, but external towards the other. And then they need to learn the skills, of course, of how you work a decision-making cycle and how you look at a buying cycle rather than a selling cycle. So attitude and experience, if those two come together, then you have the good making of a potentially good salesperson.
Perfect. So now looking ahead, so shifting away from what works, etc., to a little bit about what you guys think about the future, right? A lot of things changing. So I'll start with the commercial landscape and the usage landscape, and then go into the tech and the product perspective, what that looks like. So from the ops perspective, like you spoke about, adoption is changing. People are starting to look at automation more as I need to plan for this versus, or it's something that I will potentially look at a few years from now. They started at least actively exploring how to kind of incorporate, implement, and especially some of our current customers in the region, we're seeing a fair amount of adoption. Right? So they're gone from a point of I'm done with a POC, I'm done with an initial scale up, initial implementation, I want to scale up into quite a few facilities. So one, from an adoption perspective, how do you see the market changing over the next couple of years? And second, from a business model perspective, you spoke about this being a CapEx, high-tech, CapEx heavy investment kind of a business. But there is an increasing component of, I think we also hear this from our customers, of a lease model or a pay-per-use model. So how has that conversation been? Do you see that changing over the next couple of years? And would that make a dent in the adoption journey for automation in Southeast Asia or Asia?
No. No. Well, being able to offer elements such as rental or leasing or pay-per usage, paper whatever, is definitely a good. It's an additional arrow in your quiver. It's a good offer to have for certain customers. It will definitely be very useful. I remember one customer who, in a particular country, doesn't have a legal entity, doesn't own assets, so he cannot go for capital investments. He needs a rental model. So yes, it's definitely good to have. Will it change the needle from 0 to 100? No, of course not. But it's definitely something good to have. Regarding adoption rate, one observation I have in our company is that our existing multinational global customers, do all of them keep reordering? They try with one installation, they see what we have, they like what we have, it solves their problems, and they keep reordering. And that's a fantastically good point to have. It reminds me of what a wise mentor of mine once said a long time ago. A customer is not a customer until he has bought twice. Selling once is easy. Well, nothing is easy, but selling once is doable. But it's not until the customer reorders that you can really call him a customer. And then general adoption rates. Yes, the whole Chinese wave of robots, the commoditization is a threat on one hand, because it lowers the prices, makes it more difficult, etc. It increases competition. On the other hand, what something like that does is open the market. You no longer have to convince customers that robots are viable because he sees them everywhere. You only, quote unquote, only need to convince the customer that your robots and your solution is better than the other ones. And that's coming back to what I said earlier, is where integration, where customer service, and where your other value-added elements come into play, rather than just a commodity of moving goods from point A to point B.
Perfect. Thanks, Sjoerd. Maybe Nikhil, from your perspective, how do you see the landscape changing over the next couple of years?
Yeah, I think from any of our observations, adoption of robotics is definitely growing right now. But the problem is shifting a little bit more towards how do you optimize things, meaning that rather than just talking about one robot doing a particular task repetitively, now the conversations are more about how do you exchange information, how do you actually optimize the material flow through that entire facility, how do you bring out more efficiency out of the robots, right? The talks are more along these lines, actually. That's actually an interesting statement to say. It means that it's already accepted that robots are going to work, so they're just going to be put there. And then and then all the talks now are about how much more can you derive out of this. That's actually a very good place to be. That's for the next. I would say, I mean, the question was more about next couple of years. If we're seeing a little bit further out from there, looking at the current trends, definitely there's going to be a surge in adoption of physical AI, slowly but steadily. I think that will really help. I think I spoke about this a little earlier as well. Repeat what you see is something that would be really cool to see in the future, actually. Barring all the safety aspects that we discussed, obviously, we do need to make those systems very safe as well. But that's definitely an area to look out for.
Yeah, absolutely. I think interesting points. I think definitely system level intelligence becoming a trend, but also becoming a form of differentiation versus pure hardware specifications. And that's seems like the general trend in the industry. So I think a lot of the session is focused on people getting into robotics. I think there's two kinds, right? One is someone who's just entering the workforce for the first time, getting into the space. And then there's people who's already somewhat in the career, spend a few years in a different industry, but love the field robotics, want to kind of get involved. So if either from both of you would love to kind of get your words or message to that person who's fresher or a person who's midway in the career. What's that?
Well, if you're excited by an environment where everything is not done and dusted and set in its grooves, and you like to contribute and to build something that is future oriented and that is growing and that does solve real world problems, that's very important too, then a startup environment and a robotics environment is a very, very gratifying space to be in, because you tick all of those boxes. And so I can advise it to people who do get excited by building something, by building an organization, by building a solution that is out there in the world solving real world problems. I think that's a great place to be.
Perfect. Thanks, Sjoerd. Maybe Nikhil from your end.
If you want to see your fundamentals materialize into something that moves, and if you actually enjoy seeing your work out there, like truly seeing your work out there in terms of a physical manifestation of it, then robotics is definitely the space to be. I think for young engineers, definitely it's one of those sectors where you end up learning so much actually, that you have like all the skill sets that are necessary to dive into like any discipline in the future. So that's definitely one takeaway that I've had personally, and that I would like to share for everyone else.
All right, perfect. I think that's the end of our session for today. Thanks, Sjoerd, Nikhil, for taking the time. Pleasure.
Thank you. Pleasure.
Thank you.